Okay guys, in the next section of the graphic organizer, we're going to talk about three things, three checks that you need to go through in your head when you're dealing with any expression or problem that has square roots in them. Okay. First and foremost, it's not proper notation to have a square root in the denominator of any fraction. So let's say you get an answer and you end up with a square root on the bottom of the fraction. You can't do that. You got to do a process what's called rationalizing the denominator. We're going to talk about that in just a second. The next two checks are simplify the square root if possible, and of course simplify your fractions if possible. So when dealing with square roots, say, did I do this, did I do this, did I do this, check, 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 you're done. Okay. What is rationalizing the denominator? Well, as I said, it gets rid of this first check. You cannot have square roots in the denominator, so what does it do? It gets rid of the square roots in the denominator of a fraction. Okay, so it gets rid of the square roots in the denominator of the fraction. Basically what you do is you're multiplying by a special count of 1. Okay, so let's look at this example. I have the square root of 2 over the square root of 3. They're both simplified. I can't break them down. They're both prime. So basically that's as far as they can go as far as the square roots are. But we have a problem. We can't have this guy on the bottom, square root of 3. So you're going to hear me say this a lot. That makes me sad. So what I need to do is I need to multiply by what's making me sad. The square root of 3 is making me sad, so I'm going to multiply by square root of 3 over square root of 3. Okay, now remember, this is just a fancy way of saying 1. And if you multiply anything by 1, you're not changing the value. In this case, we're only changing the way it looks. Okay? So when you multiply fractions, remember you multiply across the top and across the bottom. So top times top, so I get square root of 2 times the square root of 3. And then bottom times bottom, I get square root of 3 times the square root of 3. Remember the product rule from up top says I can separate these, or I can put them in the same house. Okay, I can put them in separate houses, or I can put them in the same house. Same thing on the bottom. I went ahead and did 3 times 3 and got 9. So what I get now is I get the square root of 6 over the square root of 9. And you may be like in your head, Coach, hey, we just went from square root of 2 over square root of 3 to square root of 6 over square root of 9. We didn't do anything because we still have a square root on the bottom. But look at the square root on the bottom. This is a perfect square. And the square root of a perfect square should come out to be a nice number. So we get square root of 6 over 3 because the square root of 9 becomes 3. Okay, so we rationalize the denominator. Rationalizing the denominator multiplies by a special looking 1 to get rid of the square root on the bottom. Okay, let's go through our checklist. Did we get rid of the square root on the bottom? Yes. Okay, second check. Can we simplify the square root of 6? Actually, square root of 6 is 2 times 3, but there's no pairs there, so it's actually simplified. And the last one says, can you simplify the fraction? Now, can I divide 6 by 3? Well, if this was a regular 6, I could, but this is not a regular 6. This is a square root of 6. And remember, you can't mix oil and water. So, I cannot simplify this anymore. That is my answer. Square root of 6 over 3. Okay, next problem. Square root of 20 over 6 times the square root of 5. A couple ways you could do this. You could start with the simplification first, or you can rationalize the denominator first. Either way, you should get the same answer. I'm going to start with rationalizing the denominator. This is the part that makes me sad. So that is what I'm going to multiply by. Remember, you multiply by the same thing on the top and the bottom because this is a fancy way of saying 1. And when you multiply by 1, you are not changing the value. In this case, we're just going to change the way it looks. So, they're in separate houses. I'm going to multiply across the top and put them in the same house and get the square root of 100. And on the bottom, I can't mix oil and water, so these won't mix. So this 6 won't mix with this square root of 5 either, but I can put these two together in the same house and multiply them and get 6 times the square root of 25. Okay. Oh, that makes me happy because it is a perfect square. So I get square root of 100 over 6 times 5, and the 5 comes from the square root of 25. Square root of 25 is 5. Okay, 6 times 5 gives me 30. So I get the square root of 100 over 30. Okay, but I'm not done. Remember my checks. I got rid of the square root on the bottom, but the next check is can you simplify the square root? Well, yes I can. 100 breaks down. Actually, 100 is actually a perfect square itself, so that makes me even happier. So the square root of 100 is going to give me 10, and I get 10 over 30. And remember, the last step is simplify the fraction, and I can simplify this by 10 and get 1/3. So the square root of 20 over 6 times the square root of 5 actually reduces to 1/3. It's pretty cool. Let me show you another way real quick of how to simplify this. What I'm going to do is I'm going to rewrite the problem. Square root of 20 over 6 times the square root of 5. Remember I said that you can simplify before you rationalize? And sometimes it may be quick to do that. Let's do the simplification of 20 first. Square root of 20 is actually the square root of 4 times the square root of 5. 4 times 5 gives me 20. Now why did I choose the 4? Remember the method up here that said, hey, pick perfect squares out? That's the method I chose. I picked the perfect square of 4. Okay, I'm going to rewrite the bottom here. Square root of 4 gives me 2 times the square root of 5 over 6 times the square root of 5. Ah, tricky. Look right here. Square root of 5 over square root of 5, they reduce. I can actually cross them out. When you have the same thing on the top and the bottom, you can reduce them. Look, Ma, no rationalization. So I get 2 over 6. And then I'm going to simplify 2 over 6 to 1/3, and the 1/3 is the same 1/3 that I got here. 2 ways to do the same problem. Pretty cool stuff. Okay? Alright, last but not least is the square root of 120 over 8. Now, this is a big square root. Alright, they're both in the same house. Remember, there's a property that says that if they're in the same house, you can separate them. That's if we multiply it, but it works also for division. Okay. All right. Remember the 3 steps is if I put these in separate houses, this is going to make me sad. So really, this problem does make me sad, and I am going to have to rationalize. Okay. But let's see if we can be quick here and reduce our fraction before we even separate the houses. In other words, 120 over 8 can be reduced by 4, and I would get 30 over 2. 120 divided by 4 is 30. 8 divided by 4 is 2. Okay. Well, actually 30 divided by 2 is nice and even. It comes out to be 15. So you see, this problem that looked very large actually comes out to be something that's not too bad. Okay. Well, what we thought we were going to have to rationalize, there is no denominator now, but there is really. It's over 1. Okay. But it doesn't make me sad anymore. It makes me happy. And the square root of 15. The prime factorization of 15 is 3 times 5. There's no pairs. There's no perfect squares. So guess what? That's actually the answer here. Okay. So sometimes what looks to be a very complex problem is actually very quick, and you can reduce it down. Okay. As you can see, I'm still at school. We finished the graphic organizer. It's nice and neat here. Tomorrow in class, you're going to work on some problems. So be prepared, and I will see you tomorrow.